There are two different ways to calculate the amount of lime that you need to add. One is the conventional method. Let's talk about this first. So let's say we have an example where we have calcium ion as 100 milligrams per liter, total hardness as 300 milligrams per liter, bicarbonate alkalinity at 250 milligrams per liter, and carbon dioxide at 25 milligrams per liter. The lime concentration in milligrams per liter that you need to add is the concentration of carbon dioxide plus the concentration of bicarbonate plus the concentration of magnesium plus any excess that you're adding. Now if we look at the example that we have here, we can tell that each of these constituents is there except for the magnesium. And there's an assumption, since we know calcium ion, that the remaining hardness is in fact magnesium. Now we're going to convert all of these to calcium carbonate equivalents using equivalent weights. So the calcium ion, we have 100 milligrams per liter, and we're going to multiply that times 50 divided by 20. 50 is the equivalent weight of calcium carbonate, and 20 is the equivalent weight of the calcium, to get 250 milligrams per liter. Total hardness is already as CaCO3, so you can tell very quickly that the magnesium is going to be the difference between 300 and 250 milligrams per liter. The bicarbonate we said was as bicarbonate, so that's 250 milligrams per liter times 50 divided by 61, the equivalent weights of CaCO3 and bicarbonate, to give you 205 milligrams per liter. Carbon dioxide is 25 milligrams per liter. The equivalent weights are 50 divided by 22 for a total of 56.8 milligrams per liter as CaCO3. Now when we're going to figure out what each of these constituents is, we plug them into our equation that you see highlighted in white. The carbon dioxide concentration as CaCO3 is 56.8, plus the 205, which is the bicarbonate, plus we're going to add the 50 magnesium, plus the 35 extra, and then we're going to get a total of approximately 350 milligrams per liter of lime is the dose we need to add. Now let's take a look at exactly what's really happening in this situation. Let's look at the chemical equations. First of all, we have calcium bicarbonate. That's CaHCO3 squared. When we add lime to this, what's going to happen is we get calcium carbonate that settles plus water. We also have magnesium bicarbonate. When we add lime to that, we get calcium carbonate, which settles, and we get magnesium carbonate. Magnesium carbonate doesn't settle immediately, so what happens then is we need to add more lime. So that's the next equation. We take magnesium carbonate, we add calcium hydroxide, lime to it, and we get magnesium hydroxide that settles and calcium carbonate that settles. What this does is it basically is telling you that we're removing both constituents, the calcium carbonate and the magnesium hydroxide, by raising the pH. And keep in mind, typically, the only way we're going to be able to get down to the right levels to keep the pH high enough. And at the same time, we're never going to get below about 10 milligrams per liter of magnesium as CaCO3 and 30 milligrams per liter of calcium as CaCO3. Now we have some further lime reactions, so let's look at carbon dioxide. When we take carbon dioxide and we add it to lime, we get calcium carbonate that settles in water. Magnesium chloride, because remember we're trying to get rid of the polyvalent positive ions. So magnesium chloride, magnesium is the polyvalent, we're going to add lime to that and we get magnesium hydroxide, but we get calcium chloride, and that doesn't settle in this form. So we need to set that aside for a moment. Magnesium sulfate, when we add lime to it, we get magnesium hydroxide that settles, and we get calcium sulfate, which does not. So we need to figure out a way to get rid of those two calcium constituents, and that's where soda ash comes into play. The soda ash is specifically oriented to take the calcium sulfate and the calcium chloride, add the soda ash, the Na2CO3 to it, and we get the calcium carbonate to settle in both cases. Now, the one issue to be concerned about is if you have a lot of sodium in your water. The addition of soda ash adds sodium.